Hello, everybody. Can you guys hear me?
Yes.
Yes.
Thank you guys for waiting and really appreciate it. Give me a few moments so I can share my screen. All right, I'm gonna pause the recording right now and just remind me if I didn't restart it. So as promised, today I'm going to show you guys the requirement of the project or my expectation of what I'm going to receive for 2 projects. And since I canceled the class last week and I decided to not having the first project due at the week 10 and just have the 2 projects due at the end of the semester at the same time, which is December 5th. I believe from the Bronco Direct, that is the legitimate last day. And you can submit your projects anytime from now till December 5th at 12 p.m. Actually 12 a.m. Yeah, 12 a.m. Yeah, I'll make sure it is the end of the day, so you guys will have plenty of time of doing the project. But let's go over this. So first project, I'm gonna focus on drawing. Well, even though this class is about SolidWorks, and SolidWorks is about parts, drawing, and assembly, right? And you can't make a drawing without making the part. So pretty much the first project is making the part and the drawing. And nothing gonna be put together, so no assembly required. They're gonna be individual project, so don't form a group on this one because this one is fairly easy. I don't want to see hold out of the same thing, because I'm gonna give you the group opportunity at the second project. So this one just a solo. I want 3 drawings. All right, not just 1 drawing. I want 3 drawings, and 2 basic drawings and 1 advanced drawing. So 2 basic drawing can be like the easy one. Like for example, like at the beginning of the class, at the beginning of the semester, I show you guys the PowerPoint. Let's see. Let me bring up the PowerPoint. Okay. So let's consider a basic drawing. It pretty much doesn't have anything, just dimension. Yeah, this PowerPoint I posted on Canvas. So under file, I believe. So this is a good reference about basic drawing. Pretty much very simple. You just lay out the part and have multiple views, and do a little bit detail view or cross-sectional view, and just to fully display the dimensions and details of this part. And it could be a very simple part. Like this flange is a very simple part. It generated by pretty much just 2 features, right? So I want 2 of these. It shouldn't take much of your time. I'll say if you're pretty familiar with SolidWorks, it might only take you maybe 5 minutes. And if you're a first-time user, it might take you maybe half an hour to 1 hour max. So 2 of these and 1 advanced drawing. The advanced drawing, it comes with additional requirements. Okay, so this is for all 3 drawings. It could either be real or imaginary. So if you want to do something like from Star Wars or from some science fiction, like just any part. So this is my jetpack. Yes, you can do that. It doesn't have to be real, and you can dimension whatever you want, right? Let's say like I'm building something huge, like gonna be like 300 inches or something like that. Yeah, go ahead, no problem. As long as you're drawing in red format and totally define the part, and you'll get the credit. And the advanced drawing will have additional requirements, contain at least 2 customized datums. So I want you to specify at least 2 datums, and I'll explain that later. like what's the datum, how to do the datum, and at least 4 different tolerance symbols. You guys must review the GD&T color chart I posted on Canvas last week, right? Pretty much I told you guys just to study it 2 weeks ago, and you guys have entire last week to read through it. And I find out that one is pretty helpful because it pretty much explains everything. I'm gonna go over it shortly, but it's not gonna be as detailed as those textbook style. So I need 4 different symbols. All right, don't put like the same. The same doesn't count, but do put like if you have repetitive symbols and that's required by your model, do put it on there. Okay, don't think okay I put this extra one and it doesn't count for any extra credit or something, then you missed it. Don't like still fully define your model. Okay. The smallest tolerance should not be smaller than 1 thou. Yeah, this is pretty standard. Don't go over like 0.0001 or something. Like 1 thou is pretty much the minimum of the industry. And in terms of submission, I'm gonna create a like assignment on Canvas. So you guys just need to submit it on Canvas. I hope it worked the same as the Blackboard. I never tried Canvas, but the SolidWorks has no problem, just submit on it. Sorry, the Blackboard has no problem by submitting onto it. So I hope Canvas does the same thing, like nothing tricky. I'll find out. And if it does differently, I will change the way to receive this project from you. And label material, surface finish into no section. Yeah, this is easy. You just type in like 2 lines of words and you get the credit, right? I just want you to stay this so that I don't forget it, because you're making a machine drawing, right? Without the material being specified or surface finish being specified, that's not a drawing. That's like a defect drawing, all right? And then early submission, I give it 10%. Anything turned in before this date, like December 4th, for example, you get 10% of this project. So that means another 5% of your grade. All right. But you need to turn in like the real project. If you turn in like some like unreadable stuff and say, oh, I turned in my project early, you're not gonna get anything. All right. That has to be like the real project. And anything on this date, December 5th, we'll treat as normal. Anything after this date, I'm not gonna take it, because pretty much, I'm gonna calculate everybody's grade at the end of this date and submit it through Bronco Direct. Once it's submitted, I'm not gonna change it. All right, so don't miss that date. If you think you're gonna have a very heavy loaded final week, you have no time to do this right, do it early, start it early, and you will get rewarded by doing so. Yeah, yeah. So that's the only 2 assignments you guys will have. So it sounds pretty easy, right? You guys, and literally, you don't need to turn in anything until the last day of the semester. And you turn it early, I give you a reward, which is 10% of each project. Sounds nice, right? Okay, somebody asked me if we turned it in early, can we resubmit the drawings? Like, what do you mean by that? How, why you need to resubmit the drawings? Oh, I see. Well, in that case, not necessarily, because I'm gonna show you exactly what my expectation is, right? So, basic drawing look like this, and if you really like do it incorrectly, how wrong can you go, right? If you miss like 4 dimensions of one view, that like you can spot it immediately. You don't need my comment to fix it, right? If you just miss one dimension, like, oh, I forgot to label it, I mean, I'm not gonna like be super picky on it, you know. And plus, if you're turning early, you get 10%. I think that will cover the most of your mistakes, right? I'm not like gonna, okay, you missed something, you missed the center line, I'm gonna deduct like 50% of your grade. No, I'm not that kind of guy. Yeah, so I'm gonna jump into the second project later. So the 10% is just for this project, which is 5% total grade. All right, it is not your 10% of the total grade. And the final project, which is the second project, it's gonna be assembly. So I have seen how you guys made the part and the drawing, and now it's the turn to see how you guys make assembly. And it with the same 50% as stated in syllabus, and due date the same. And since the due dates are same, so there's really no first or second project. You guys can pick whatever to do first. However, the drawings are easier, and I'm gonna show you how to make drawing today. So pretty much after today's lecture, you guys are able to start making drawings without any problem. But the assembly, I'm gonna start showing you guys how to make that line for an engine, parts by parts. So that's gonna take a couple of weeks. And if you need to follow the recording to make the engine, that not gonna be finished till maybe week 12 or week 13. So I suggest you start the first project early. I mean, start the first project first, and then after you've done that, the recordings are all set, and you can start working on the engine assembly. So I gave you guys a little bit of freedom in the second project. It could be individual, it could be grouped. It's up to you, but don't make like the group contains half of the class. So max 5 people max. All right. And if you're forming a group, then let me know your group member's name. And just send me an email, so I'll keep in mind like who will be submitting similar stuff, right? Because everybody do the drawings and the model in a different style. Some similarity is permitted, but you know, if it's turning exactly same thing, the same orientation, you know, I don't like that. And I will check names by then. The assembly need to contain at least 10 different components. So if you're doing engine assembly, that's more than 10 different components. So you don't have to worry about this requirement. And I don't require you to do the engine assembly for the second project. You can also do something else. Like last year, somebody did like a train, and somebody did a little the toy airplane, those propeller ones. And somebody did like I remember somebody did something really fancy, like a V8 or something. So you can also do something else as long as it has 10 different parts. And it could be 10 exactly 10 different parts. Like the train I have seen, like that's 10 exactly different parts, like a toy train. But it looks pretty good. And no drawing required. So this time you just need to work in parts and assembly. You make the parts first and assemble them together in assembly. And no PDF will be required. So in terms of turning in this turning this project, I want you to make a report. Okay. The report should contain the screenshot. So if you don't have any screenshot software, just use the Windows default snipping tool and just snip the whole thing. Okay, the whole window, including a text bar, if you do have one showing up, and copy and paste it to Word and make a final assembly report. Okay, and I want you to make the screenshot of every single part and then the assembly. So you should have at least 11 different screenshots. So one shot per page, your report if you don't have a cover page. I like a cover page, but if you don't have a cover page, your report should have at least 11 pages. Okay, understand? Everybody, please type something in chat showing you just heard what I'm saying.
So it's just gonna be the pictures. Is that what you're saying?
Yep, that's just gonna be the pictures.
Okay.
But I want the whole window snipped. And also don't put your part or assembly in a weird view of orientation. So if you're making the engine, the isometric view is perfect. If you put like something, let's say, like for example, this part look like this, right? If you snip it like that, fine, I'll take it. Looks pretty good. And if you snip it like this, I can't even tell like what is this part? Are you making a wheel or are you making something else? Then it is not good. All right. I hope this is not too much to ask. Yeah, I'll show you an example of advanced drawing. Okay. So if you have any question regarding this project requirement Word doc, let me know right now. I haven't posted on Canvas yet because I want to see you guys' feedback so I can make modification right away. If you guys have no problem, everybody agree, then we're gonna follow the rules.
Professor,
Yes.
for project one, you know how it's saying that we need 3 drawings? Can those
Mhm.
drawings be from like the final project if we're already like working on both of them simultaneously?
Ah, good question. Yes, it can.
Okay, cool. Thank you.
Yeah, no problem. Yep. So that's gonna save you a little bit of effort of making the part, right? The flange that we created in class 2 weeks ago count as the final project as the technical. The flange? You mean the 2 clamps with a tube? The assembly? Uh-huh. Really? That assembly has 10 different components? Well, that assembly doesn't have 10 different components. So yeah, if you use that clamp, that small assembly, you're not gonna get full credit. Yeah, you can use the parts of the final projects for the first project. However, I'm gonna show you guys how to make the engine assembly parts by parts, maybe in 3 weeks. So you guys sure you won't wait that long for the first project? That will make you, last couple of weeks really packed. I'm trying to release the stress of you guys, but it's your choice to really do it stress-free or really stress you out for the last couple of weeks. Yeah, the engine can be your final projects. Any more questions?
Professor, could we possibly see some drawing examples?
Yeah, I'll show you examples. I just after I finished up this, I already got it open up, you see, like which I show you guys the first day. Okay, no questions. So I'm gonna get it saved and I'll upload it to Canvas right after the class. So this is what we all agree, especially the deadline. If you submit it, once the calendar turns into December 6th, I'm not gonna take anything. Okay, so be real careful about the deadline, and each project is 50% of your grade. So if you missed one, you're failing for sure. All right. Before we jump into the drawing, let's do some warm up. This is a little exercise. Just hope can refresh your memory about the dimensioning and the dimensioning rules and also the tolerance. So everybody take out your calculator or sketch paper. Calculate what's A. Well, I need a value for A. Well, should A just be a single value or it should be a range, kind of like the other two dimensions? Yeah, that's right. If it should be a range, please give me a range. Okay, I've seen one answer. Anybody else? Okay, I've seen another one. Yeah, don't waste this opportunity to practice because they're gonna review a lot of like a lot of materials, and is if you get it wrong, is pretty good chance pretty good opportunity to ask question. Any more? All right. So the correct answer is 0.8 to 1.17. And how do we get that? So how many values this possibly can be? It could be a lot, right? But the biggest A could be is the biggest of this value minus the smallest of this value, right? So that would be the maximum of A, which is 2.12 minus 0.95. That yields 1.17. And vice versa, the least amount minus the max amount of this, they're gonna give you the smallest A, which is 1.9 minus 1.1, that's 0.8. That's how you get to 0.8 to 1.17. Any questions about it? Okay, if you got no question, I got a question for you. So if I now replace this A to the value we just calculated, which is 0.8 to 1.17, is it correct? Or can I define A that way so this view is still legal? Can we do that? Yes or no? So I see yes. Anybody else? Hello, anybody? Okay, now I see people coming with different opinions. Well, no, it's not going to be legal because this, the length of this side can be 1.1, can be 0.95, right? Or could be any value in between. If this value is 1.1 and we put A as 0.8 to 1.7, and then we take the maximum of this one, they're going to be 1.1 plus 1.17, right? And what's that going to yield us? They're going to yield us 2.27, right? And 2.27, does that lie into this range? Yeah, so you see why is not legal, right? That means you have a drawing mistake. Yeah, so this is what I want to show you guys. And normally, if you define the over length, and this length contains different different sublength, or that kind of stuff, you just need to define one, or I mean, you need to leave at least one section alone, because if you define every single section and then you define the overall length, that's over defining. So one of the very important rule of dimensioning is never over dimensioning, never put two dimensions over one subject, because they're going to be conflict. So from here, you can see this is the total length, right? And it break down to 3 different areas, and only 2 of the areas are defined. This one right here has nothing. That's why this B needs to be calculated, not stated, okay, or not defined. If you define this, then this overall dimension will have conflicts with that 3 being adding up. So another way to do it is you can define every single section or segment of the length and not defining the overall. But the downside of doing that is lost control of the overall. So the quality will have to measure each individual length and then calculate an overall length for you to say, okay, what is the overall dimension of this part? Instead of can just tell you if the overall dimension of this part is qualified or not. So pretty much all other examples are similar. This one, it defines section by section, and then you need to calculate the overall, right? Which is what I just said. And this one is only define one of it, and even though these two might look, the same, but I don't know if they're the same. And you need to calculate one of it. Well, it is the same, yeah, because the center point is right here, so that's a perfect semicircle. And also this one is 4 different sections, and you need to define you need to calculate the overall length. And same thing right here, same thing right here. So when you make your drawing, don't over defining, because you can add no matter how many dimensions you like onto the same view or even the same model. So just be careful of that. After you made your drawing, for example, this one, after you made this, try to go dimension by dimension to see if you can make this part by lathe or mill, whatever in your mind. And if you can make this, that's good. And to see, okay, without this dimension, can I still make this part? If the answer is yes, then you're over defining. If the answer is no, then good. That's the primary dimension you need. Okay. Give me 1 second. Let me close the door. Hello, everybody still there?
Yes.
Yes.
Oh, okay, thank you. All right. You guys want this practice? Yeah, if you guys want it, you can take a screenshot right now and just, you're welcome to email me for your potential answer, and I'll tell you if you get it correctly or not, just or I can post the solution on Canvas next week. So you guys can have a little bit of practice, totally voluntary. So up to you.
Professor, would you be able to post the solutions?
Yeah, I'll post it next week, so I don't spoil any solutions in advance. If I didn't do it, just remind me. I can post it anytime. Okay, so let's go to this drawing. Okay, so this drawing, let's look at the model first. So give you guys a comprehensive understanding of what this model does and what kind of feature it has. So this is actually an industrial part, which I worked on like a few years ago. So it is a driver support. By it means you're gonna support a driver, right? A driver, normally electric motor. So in some industry, call it just called driver. So the electrical motor gonna sit on the top right here. And the base of the electrical motor is matching this plate dimension. So the motor base is circular, has the same or smaller diameter than the OD of the top plate. And these 4 holes with cosmetic thread is going to secure the motor. So the motor will have another 4 holes, and when the motor is sitting on top of it, and these 4 holes match position, and you're gonna have bolts and nuts to secure the motor on top. And the bottom is just well, I don't want to introduce too much, but the bottom, let's just pretend it's gonna sit on the ground, and these are gonna be the bolts that is going to the ground, work as anchor bolts. And the middle is hollow, is because since it's a electric motor, you're gonna driving a shaft. So it's a vertical shaft, go through the top opening and the bottom bore, and it rotates, and is rotating equipment. So you're gonna do something. And these windows, you can see 2 big windows and 2 small windows are for maintenance, because the configuration you will have is a coupling that connects the shaft and the motor shaft, right? 2 shafts cannot be linked together unless you have a coupling. So these 2 big windows are for installation or maintenance of the coupling. And the 2 small windows are just made to reduce weight. This whole thing is made either by stainless steel or pretty much just stainless steel. And so that's why it'll be heavy. Since it's doing structural support, it cannot be made by aluminum. So something to remove material is necessary. That's why the top opening is so big. The bottom opening is small, is because it has some parts go around the shaft. We don't want like whatever the liquid from the bottom to come up. We call it a mechanical seal, but I'm not going to talk too much about that. That's why the bottom bore is well controlled, but the top opening is not, because pretty much we can open it even bigger just to leave enough material for this flange connections, so that we can, you know, optimize it to have the least weight. So anyway, this is the symmetric part and made that pretty easy. One feature, boom, is done. And all the other features are either the holes or the opening, and they're relatively very simple. Kind of you can treat it as cosmetics. So let's look at the drawing. It's an easy part, done with one feature, even though in reality it's not. But in this class, let's just treat it. It's casted, it's just done with one feature. And you know, after the casting, it pretty much almost look like this, and we just need to machine the bore, machine the window, and you know, tap holes and all that. Okay, let's just pretend that way. So similar to this drawing has 1, 2, 3, 4, 5 different views, right? And the fifth one doesn't do anything. It's just an isometric view to show you the overall configuration. And 1, 2, 3, 4, 5. Okay, so remember this: for every drawing, you will need about 5 pictures. Sorry, about 5 views. Even though it's not necessarily to have all 5, if you remove this one, it could still be a basic drawing, but you know, you need to fully define your model. And from here, you can see there are no there are dimensions, there are nodes, and there are GDNT symbols. Well, how do I sketch the model in SOLIDWORKS? You mean the drawing or the model? The model, you're supposed to know how to do it. If I gave you the dimension of the part, it's just a simple revolve, right? And the drawing, I'm gonna show it right away. But I need to talk about those datum and GDNT first. So this view, very similar. I wish I can show them at the same time. Okay, but anyway, this view is the top view. Pretty much look at the part from the top, very similar to that, right? And this is a side view and very similar to this. And this is a cross-sectional view and very similar to this. And you know, detail view look like that. So pretty much advanced drawing is just an upgrade of simple drawings or basic drawings. You just need to add more control elements, GDNTs, and the nodes, and customized tolerance, and something detailed that you know you're doing. You know what you're doing. All right, let's try to make this drawing. All right. So once you have this part, I'm not gonna make this part again, but pretty much look at the default templates of SOLIDWORKS. And you see this one is pretty much 8.5 by okay, this is such a weird size. Huh. Okay, but I don't, well, anyway, let's just use A2 for now. All right. Oh yeah, now it's good. So this is 11 by 17. Should be 11 by 8.5, but I don't know why they're fractions like that. But anyway, let's just use A2 for now. All right. So once you have that, since you're open up the new drawing from the part you just made from this page, right? We open up a new drawing, then your part supposed to automatically implement it right here. If not, you need to browse it to find it where you saved your part. So once you double click that, it will just ask you to put like any drawing, any view right here. They even show you that little box. Or you don't have to do that. And right here, okay, huh. We have to like do this first, and then this one. Hey, why is it not showing up? Okay, right here. Yep. So once you import the drawing, import the model file right here, you can see a whole lot of different orientations right here. So from
Professor, it was lagging for like a good bit, and like I don't know how like it just popped up out of nowhere. It like skipped like to where
okay,
you're at now, and I don't know how you got what you have on your screen right now.
okay. So you guys cannot see my screen, right? Can you guys still hear me?
Yeah, we can still hear you, and like we weren't able to. Your screen was frozen for like a bit, but for me personally, it just like skipped to where you're at right now. I'm
Okay.
assuming.
Yeah, I'll be back. Hello, can you guys hear me?
Yeah.
Okay, can you see the screen right now?
Yep.
Okay, my goodness. Yeah, every single time, I don't know, like when Zoom is about like 45 minutes mark or 40 minutes mark, and it's just having this, right? And it's only for Tuesday. That's so weird. Okay, but anyway, then I'll just start from beginning then. You guys know where to find this?
No, I think like since the beginning we missed
Okay.
everything.
All right, no problem. So pretty much you can close it right here, and I don't need to save it. So if you want to make a drawing of the part, like pretend this part has no drawing associated with, let's still go new. And double click the drawing. And let's do A2 as a page size. All right, even though like the dimensions are, I don't know, kind of weird to me, but let's do A2. So you'll see this as your left. Since we're making a part drawing, you only see one part, which is the part you open the drawing from. And double click on it, and it will give you a like a preview of the view, and you just need to click anywhere, and you can see one view has been implemented into this drawing, right? And another way to implement more drawings is from your right, there is a drawing symbol, and you open it up, and you see right here, you can select the part that you just made. Since we opened this new drawing from that part, right? Otherwise, you just need to browse it. And now you can see a whole lot of different orientations, like, isometric, back, left, right. And all you need to do is just drag it right here. So kind of easy, right? You just need to, first of all, drag whatever the views you think you need. Like apparently we're gonna need a top view in this case, right? Otherwise we cannot even show them we have holes in the top plate and bottom plate. So we need a top view. And what else we need? We already got a front view with the big window, and we need to show them the small window, right? So either left or right, doesn't really matter. Okay, once I drag it over here, wow. Okay, once I drag it over here, you notice there's some sort of restriction of the movement. You see, like they have a reference line linked to each other. And then you can select the view and go to alignment right here to break alignment. Once you break it, it's not going to be linked together. You can move that freely. So you might need to do this action for individual views if you don't like them to be linked to each other. And if you want it to go back, you can always go alignment and default alignment and okay, this is kind of yeah, this is a little bit strange. But let's see. Okay, let's create a new view and it has reference line on it. Once we break it, we can drag it freely and we can resume it just by default alignment. Okay. So normally we don't want them to be aligned together and you don't want your view to be moved freely. You can always lock your view right here. So lock view position or lock view focus. So use lock view position and it cannot be moved. And also all the different views will be reflect on your left side. This is similar to the feature tree. So this is, the drawing tree. And if you like to delete any particular ones, you can delete from here as well. So the isometric view is gone. So, let's see. So we have a top view. Oh, this is a bottom view. Okay. Okay, so we have our top view right here and the front view over there. And this view, we do not necessarily need it because we can always have the project view of the top view. So once we do that, it'll show as horizontally so that we can save some space, and also there are more features can be indicated. So once we have the views implemented, you will see these are look very small, right? You click on the view and here are a whole bunch of modifications we can done to it. The scale is one at the bottom right here. You can use customize scale to make it bigger. So the smaller number, it goes the bigger. And same thing right here. Since these two views are linked together, so you increase one and the other one they share the same setting. So however, this one will be different. Okay. Once you have the views, we can start implement dimensions. And dimensions will be under annotation. So all the dimensions, the nodes, the balloons, and everything, even datums and all that, they're annotation. Just like when you open up the drop-down list, you'll see your parts right here and your annotation right here. So these are what you're trying to add to your drawing. So you can go with model item first, which is the dimension that you use to build your model, or you can use smart dimension. However, the smart dimension you created is not the driving dimension. Okay, they too will have a different name ID. So let's do the model item first. You select one view, and the dimensions right here are gonna ask you like, what do you need? You know, for first time, we always click everything. Just this, okay, we want them all. And annotations, those datums and all the nodes and all that, like let's select them all. And reference geometries, it has, you know, reference plane, axis, and all that. You can select them all. But like, if you know what you're doing, then you won't select them all. But I just want to show you guys. No model item was inserted. Should use to change import form option to entire model and try it again. Okay, so the source initially we select is not the entire model. So right here, the source, either entire model or not. Since this is the easy part, just made by one feature. So of course, it only has one option. If it's made by like, you know, multiple steps or something, like you can choose to have them show like separately. So now you can see everything is overlap each other and we have so many different stuff. So for example, like this whole, so this hole, we have a 3/4, cursor and 0.5 depth and 4 holes. And right here we have 4 holes with 0.66 diameter and 1/2 inch depth and 3/4 cores 1/2 inch depth. So these are pretty much overlapping each other because we tell them to show all of it, whatever they could show. And you see right here is so hard to clean them up. And even the reference number showed up. And even something is not displaying right showed up too. See, there's 8, there's number 2. And guess what? Those are the number of holes. So the bottom holes as number of 8 and top holes as number of 4, and even those showed up. But apparently we don't need them, right? But let's use this opportunity to see the property of the dimension. You click on any property and you will see this pops up and it gave you some options to make modifications, right? Right here under primary value, it says D4 as sketch 1 and 1.75. And you notice like this value can be modified. If I say like 1.88, it will change to 1.88. And if I control Q it to resolve it, like it will change the model directly. All right. However, if we use smart dimension inside of the model item, and let's dimension this 1.75, right? Because we have not resolved it yet. Let's change it back. Yeah, I just don't want the model changed in the middle of something. This 1.75 is generated by the model item, and this 1.75 is generated by smart dimension. They look the same, right? Hard to tell the difference. But under the primary value, it says D4 as sketch 1, and 1.75 can be modified. This dimension Under primary value, it says RD2 and 1.75 dimmed out. You cannot modify this because this is not primary dimension. Or we say that this is not a driving dimension. This is the driven one. So that gave you the difference that the privilege of different dimensions. So a good designer, he know what he's doing, and he can just during the modeling phase, they model it correctly. So during the drawing, they don't do much. They just use model item to import all the annotations and make the nice the nice setting, and make them look better, certain style, and that's it. Their job is done. But for you, most likely you would need to use smart dimensions more than modeling item, because a lot of dimensions will not be showing up correctly in the corresponding view because you didn't model it correctly. Okay, this is a very important information, even though there's always more than one way to make a drawing right, because eventually the drawing is just a piece of paper. You just print it out as a PDF. Nobody would ever notice the difference between that 1.75 or this 1.75. But if you keep working on your modeling, for example, this is the repetitive part, we're gonna keep using the same part for a different project, and anytime, every single time, we just need to do a little bit customization or modification to it. Then it's very important for you to model it correctly the first time. Otherwise, you're just gonna bring a pain every single time you try to use it, unless you remake this and start over. So for dimensions, all right, sorry, I missed a question. Does it matter when we put each view of the object on the sketch paper? No, not necessarily. Just like that flange, the front view and the right view, pretty much the same thing. You only need to put one view on it. You, as an engineer, need to make the call. How can you fully define your model? Like how many views and how many dimensions can fully define your model? And that process should be done at the modeling phase, not the drawing phase. I mean, the thought process. So, I showed last time, right? Under leader, and you can always have something to make it a little bit better. And the leader style, can be something like that. They're just minor things to make the modifications. For a basic drawing, it will be extremely easy because you just need to place the dimension right and in the right place, and also have enough of dimension to define a model. In the advanced drawing, you will need to specify what the feature is. For example, this hole. This hole, when we make this hole, we only say, okay, it's 0.5, it's 0.5 diameter. And let me finish this and I'll answer that. But after, okay, even though it pops straight up when I do the model annotation, is because I have done the drawing one more time. So SolidWorks has its own memory. So this is manually typed, okay? When you first import the annotation, it should just look like that, like 0.5, similar to the 12.5. And you need to add whatever you need to let the machinist know about your feature. So same thing as this. This 0.5, it has eight places, right? So of course we're gonna say 8 places, or everything must be capital. Remember, every note must be capital. So 8 places or 8 holes. whatever you think is better to describe it. And these holes are straddle center line. You can see the center line is right here, right? So this is the center line. Wait, why is center line? And these 4 holes are straddle the center line, like 2 right here. So we don't have to define this hole is 45-degree from the center line. They will know what to do. But these holes are right on the center line. So we don't need to define anything since these crossing lines are right at the center of these holes. And same thing, make it horizontal. Horizontal always make it neater, right? Okay. So once you have the dimension, you can now implement the tolerance symbol. So pretty much just search tolerance or geometric tolerance is right here. Either way, you click on that, they're gonna bring up the preview of the GDNT symbol, and you can select the proper symbol of this hole. They're gonna be true position, right? And the tolerance normally is 14 thou. This is just an industrial standard. And the primary plane, you will need to go back to the project requirement document. You will see which one is required or not. So for example, I mean, just making things up. I haven't even defined the datum yet, but I'm just making things up for this GDNT symbol. So we have a true positioning tolerance need to define, and we have the true positioning is always have 2 or even 3 reference plane. So 2 is minimal. We reference with datum A and datum B, and we define that with a proper tolerance, and that's okay. Okay, it generated right here. We can move it underneath. So normally this will do the trick. And if you want to be more precise, you can drag this until this dimension is highlighted. So that completely merged with that dimension. All right, so either way, but this is pretty much once it's merged with dimension, you cannot do anything about it unless you delete it. You know, you cannot like separate them again. At least I didn't find a way to separate them. So all right, yeah, I gotta do that again. So normally, yeah, normally this would do. So at least it gave you some freedom to make the arrangement, you know, for about the positioning. And also, for the section view, right here, we can see auxiliary view, section view, remove section, and detail view and relative view. So these are all the features you can play with. And let's talk about the section view for now. Once you make the section, once you click that, you will need to hover over like a view right here or that. Like for example, let's use this first. All right. So a cross section is being made, and this is the section AA, And I believe we're going there. You can change his name. If I don't want to call it A, I want to call it B, and you can do it so. And you can either partial section, slice section, auto hatching, and all that. Try it out. It's never hurt. But for your project, make a full section. It's easy and straightforward. Anything else from this? Nope. Yeah, pretty standard. Kind of like as standard as the just as a independent view. So as long as this is matching this, then it'll be fine. Well, it doesn't have to be different. The tolerance is per like what kind of standard you're using. If you're using ISO standard, like it has its own value. The 14th thou, it just I forgot by what standard, but that's what I have seen the most. And me personally, I never need to calculate the true positioning tolerance. I just use what has been used because the drawing needs to follow certain standard, right? Yeah, so yeah, you can definitely use that, or you can make it up. Like it's totally up to you. This is not about how precisely you can make this drawing correctly. It's just to give you a sense that what needs to go on there. All right. So well, the section view is right here. And if you want to make cross section of anything, you can, like for example, even this view, you can make a cross section, right? So let's do this view for an example. Okay. So wow. Okay. So this is a project view for side, and this is a cross-sectional view of this view. And see, they pretty much look the same, other than this is cut in half, and this is the whole thing. And you can tell by the hatch line is cut in half. And I remember for somewhere you can added the hash line, but whatever, that's not necessary. So the datum is under annotation right here. Yeah, the datum feature right here. Datum is a reference. So for example, you need to set this part in a, like you need to machine the you need to tap the hole for the top plate. You need to find a way to secure this part, right? And when you set it up on the milling machine, it needs to sorry, it need to be fixed from a certain coordinate. Then they can use the dimension and the tolerance of the positioning of this hole to locate the tapping point, and then they can tap it from there, right? Or drill it from there. So very commonly, when you set up a datum, you need to first consider what kind of tolerance they're gonna referencing this datum, right? So for example, if I'm setting this datum right here for the bottom plane of this subject, I'll say this is my datum A. Is this surface has anything to do to machine these 8 holes? Can someone tell me? Is this surface has anything to do with tapping one of the holes right here? These holes, not the top 4 holes. Yes or no? Come on. Just 2 people? Well, the answer is no, right? What is this surface? This surface is this surface, right? And the hole we're looking at is this hole. Why referencing this surface has anything to do with that hole? Nothing, right? It's not even in the same plane, or is like 2 separate plates, right? So in order to make this hole, we need to reference what? First of all, we need to reference the surface, right? We need to tell them, okay, drill on this surface. And secondly, we need to reference with this axis, right? This axis, the pattern of this hole is circular, and this axis is multiple or is in the position, is going through the origin of the circular pattern, right? So every time we say how to locate this hole, we need to say the bolt circle or the radius of the center distance to the origin is such and such, right? So for example, like what is the wow. So center distance is 5.25. So the bolt circle is 2 times 5.25, which is 10.5, which means this hole has a bolt circle of diameter of 10.5, which is 5.25 from the origin. That's pretty much one of the 2 things we can define the location of this hole, right? And another factor is this hole lie exactly on the center point of the bottom plate. Remember, like I firstly talked about the center point. So that's the center point, which is the intersection of the center line and bolt circle. So that's the only 2 things can define the location of the hole, right? One is this intersection, and then another one is the diametrical or radius of this bolt circle, which we stated right here is 10.5. So with that 2 factor defining the position, then we need to set up 2 datum, right? So the first datum, which right here is A, represents the axis. You can put the datum right here as well. Like for example, I just insert a C right here. It references the same thing because there's no actual edge along this line. So we're referencing the axis, which is the center axis, goes pointing inward and outwards the page. So the axis actually is a dot right here. And the second datum since we cannot like reference the center line of the plate, then we reference the edge of the plate. Okay, because it's not center line, the center line is within the plate, right? We cannot cut the plate in half, like for example, cut this one in half and say the middle plane is the datum B. Then that's why we say the OD of the top plate is datum B. Does that make sense? Hello? Okay, so let's think about the whole, let's think about this subject not look like that. The subject just look like, the subject just has this top plate, only has this part. So pretty much it's just a plate. We need to make 4 holes, right? And what kind of reference you can get to make 4 holes in its specified position? You need to fix this plate on a milling machine first, right? And how to fix it? You either have like clamp, or you either have like the block to squeeze it so it doesn't move at all, right? So one of the datum in order to fix this plate should be the outer surface, right? Pretty much like you have the tool to fix the entire plate in a certain position, right? Like the clamp can be clamped outside of the right here, and you just clamp it right there and it will move. And the other thing is the center axis. Another reference is the center axis, right? The center axis in 2D is the origin of circle, and we define circle by its radius or diameter. And the radius and diameter always come from origin, right? If we say like the pattern of these 4 holes is has a diameter of like 8 inches, that's referring with origin, right? So that will be your second reference. That's why the datum A and datum B is one this and one this. So one OD and one axis. That's the 2 minimum you will have. And if you want to do a really good job, you can reference the top surface as well. Tell them the tapping should start from the top surface. But this one is optional because pretty much every machinist or everyone would realize that from your drawing. So think about it. If you don't reference this outside diameter, what will happen? Can they still locate the tapping point of this hole and start drilling or tapping? Can they still do that? Hello? Kind of. No, you cannot, because this plate will move freely, right? So once you've done this hole and this plate moves another 5 inches, your hole will be like, your second hole will be like right here. And without this as referenced, then the drawing states these holes will lie in a circular pattern that is 8 inches diameter. And without this as an origin, that you can have the circular pattern like right here or right here, right? Kind of same deal as this play more freely. I kind of feel like I did the wrong sequence. I should go over the GDNT chart first and then jump into the drawing. So that way I don't need to explain the datum relationship with the GDNT in the middle of drawing. Okay, anyway, let's do it this time. And then next time I'll recover the, I'll cover the GDNT. So, but anyway, like the basic of drawings are pretty simple. Once you lay it out the drawing, you can start do the dimensioning. Right? You have all the dimension laid out, and you just delete the unnecessary one and follow the dimensioning tool to realign those or reposition those and make sure the leader lines are not interfering with your model, and make sure all the dimensions are outside of your view, and then you're good. And under drawing, the detail view, for example, you want to show this little feature, you click on detail view and just click any point on the feature you want to show, and it's going to generate a circle. And you just click anywhere to confirm the circle, and you can have another dependent view of the detail. And same thing, you can change the setting of that view right here, like the scale and the way it displayed. There is a wireframe and there is like the shade with edges, stuff like that. Play with it so you'll know. The drawings are much easier than modeling because it doesn't have too much, it doesn't have too many tricks. Once you know how to set up one view, then another view is fairly simple. And there are so is detail view, you just click on it and you click another time and the circle is automatically formed, and just click when the circle is big enough and you can place a view here. Okay, and same thing, you want to import the dimension. Dimensions of the sketch 2 feature, no dimensions are inserted. Dimension of the sketch 2 feature can be inserted to drawing view 1. Then what is drawing view 1? Oh, okay. Because that is a cross-sectional, so it doesn't have any dimension to be displayed. But however, for example, since we have so many views in this, since we have so many dimensions in this view, right? And we can, we're no longer getting double dimensioned from other view. Then we need to think about a way to move those dimensions from here to there, or you just delete whatever that's unnecessary. So you can move it manually, or you can delete it and reinsert it by model items, and it will show up. Wait. Let's do this first. Look pretty messy. Yeah, I should have implemented everything. This is causing me too much lag. Like this center line will probably be inserted like 4 or 5 times because this board has center line, the window has center line, this opening has center line, and this OD and that OD, they're all having center lines. Okay. Okay, here's the deal. Like today just gave you guys a little bit taste about how to like making views, and time is almost up. And for next time, I'll start with the GTNT chart. I'm gonna go over symbol by symbol, tell you exactly what the datum associated with the symbol, and then we'll go from there. And I will make this drawing step by step in the correct way. So it's not like gonna be keep trying new stuff, not keep trying new stuff, keep showing you guys the possibilities. And I'll just make this one. And then we'll show you guys what's the necessary stuff for the advanced drawing. Since the basic drawing is just a simplified version of this, right? Without the GTNC symbol, without the nose, and yeah, with the title block, and even without like the detailed view, and you just show overall dimensions and the feature dimensions, and even without the nose. Okay. How do you guys think of the plan? Oh, am I lagged again? Oh.
Sorry, Professor. What was the plan again? I like kind of lagged out for a second. I think it was just my computer though.
No, I think it's my Zoom. Like, can you see my screen? Or my screen is not moving at all?
It's just the cursor moving.
All right. Yeah, just so when is my screen froze? Was it like just now or a couple of minutes ago?
We just see your the not the picture, sorry, but like that the ones that you made. That's all we see. Like we just see like you zoomed out of it, and so we see like the whole drawings, but nothing else.
Okay. Okay. Wow, it's really bad. But anyway, give me 1 second. Let me re-enter the room. Seriously. Hello, can you guys hear me?
Yes.
Okay. What I was saying is today that's how far we got. And next time I'll begin the class with explaining the GDNT chart symbol by symbol, and I will talk about how the datum is associated with different GDNT symbols if they need them to reference with. So and also I will just make one of the advanced drawing that I think meets 100% of my expectation step by step, so you guys can have a full recording that shows what I'm looking for. How does that sound?
Sounds absolutely amazing, Professor.
Yeah, that's good.
Sure. So pretty much
I don't know if you would allow this, but like for example, like the example that you're gonna show of the advanced drawing.
Mhm.
Now, obviously not copy it, but could we kind of like make it like similar, I guess, in a way? Or do you want us to make it like completely different from your example?
I was hoping to make complete different.
Okay, I was just wondering, just asking.
Yeah, because okay. Because I didn't show you guys how to make the model. All right. If you well anyway, just make something different. Don't use this one. The way to make drawing are very similar despite what kind of model you're using. So use that recording as a technique of how to make drawings, like how to like import views, import dimensions, and adding nodes and not such and such, but don't make the same subject. So if you have no more questions, then class dismissed. If you have any questions, ask now.
I had a really quick question.
Mhm.
Could you clarify what you mean exactly by 4 different tolerance symbols for the advanced drawing?
Okay, I'll explain next time when I go through the GTNT chart.
Okay, thank you.
Thank you, Professor. Have a good one.
Thank you. You too.
Have a nice day, Professor.
No problem. Thank you.
Thank you.
Just a quick question for
Mhm.
the first project. Since it's 3 drawings, do you want 3 different parts, or do you just want one part and then 3 different versions of a drawing?
Darn, of course, 3 different parts.
Okay, yeah, just because I was confused on that.
No problem. Any more? All right, I'm gonna end the class for now. And if you have more questions, please email me.